Hello friends, in this video we will discuss a problem based on projectile motion. So two particles are fired from the same point with speeds of 100 meter per second. Both are having the same speed and firing angles with horizontal are 60 degrees and 120 degrees respectively. So the time after which we have to find the time after which their velocity vectors become perpendicular to each other. So according to the problem, it is clearly mentioned that both the particles are fired from the same point. The first one, that is the particle number A, is fired with a speed of 100 meter per second at an angle of 60 degrees. And the second particle is again thrown with the same speed but at an angle of 120 degree. Or I can indirectly say that for this second particle, the angle with negative x-axis is 60 degrees. Since in the problem it is given that the second particle is projected at an angle of 120 degrees, which indirectly implies the fact that with respect to ground, the second particle will be thrown again at an angle of 60 degree but in opposite direction. Now the initial angle between these two projectiles or initial angle between these two velocities is again equal to 60 degree. It is directly evident from this diagram that this initial angle between these two velocity vectors is equal to 60 degree, and we have to find the time when the angle between these two velocity vectors, when the angle between these two instantaneous velocity vector becomes equal to 90 degrees. So we have to find the time when both the particles are present at such positions where their velocity vectors, where their instantaneous velocity vectors, when extrapolated, will intersect or make an angle of 90 degrees with each other. And this is possible only when this angle is equals to 45 degrees. Since if this angle is equal to 45 degrees, if both these angles are equal to 45 degree, we can directly conclude that this angle alpha has to be 90 degrees, which is required in the problem. Let us now shift our focus to any one of the particles. For example, suppose we observe the particle number 1. We now know that the particle was initially thrown with a speed of 100 meter per second at an angle of 60 degree, and we have to find the time when the velocity vector of this particle makes an angle of 45 degrees with the horizontal. So I've assumed that at this instant its speed is equals to v, and since we know that the x component of velocity of projectile always remains constant, so we can write 100 cos 60 degree is equals to v cos 45 degree. From here we can say that the value of v is equals to 50 root 2. Let us now find the y component of velocity, that is I am about to find the y component of this velocity at point B. So this y component of velocity will be equal to v sine 45 degree, which is equals to 50. Let us now write the expression or equation for this particle from point A to B in y direction. Uy will be equal to 100 sine 60 degree, that is initial velocity in y direction at point A is equals to 100 sine 60 degree, that is equal to 50 root 3. Similarly, the value of Vy is already found to be equal to 50. Acceleration in y direction can be written as minus 10. So now if we apply first equation of motion, we can write v equals to u plus a into t, which on simplification gives the value of time to be equal to 5 root 3 minus 1 seconds. So this is the desired time at which both the particles will have velocities such that both these velocities when extrapolated will intersect at an angle of 90 degrees.